71 light-years from here, there is an object that astronomers cannot name. It is about the mass of Jupiter. It orbits something that is not a star, and when the team that found it sat down to write it up, they ran into a problem that had nothing to do with telescopes. They didn't have a word for it. Here is the lead author, Kevin Hoy. This system is somewhat hard to define using solar system-based words like planet and moon. That is a very polite way of saying our vocabulary just broke. In the next few minutes, I'll show you what they actually found, why nobody can agree whether it is a moon or a planet, and how on earth it could have got there. And then I'll tell you the part most of the coverage left out, because this discovery comes with a warning label, and it changes how you should hear all of it. Welcome to Arthur's Physics. The system is called CD352722, and it has 3 levels. At the top, a star, a small one, about half the mass of our Sun, and young. Orbiting that star is a brown dwarf, and a brown dwarf is one of the strangest things in astronomy. An object too heavy to be a planet and too light to be a star. It formed the way a star forms, out of a collapsing cloud of gas. And then it simply never got big enough. The pressure in its core never reached the point where hydrogen fusion switches on. It is a star that failed the audition. This one is more than 30 times the mass of Jupiter. And now the new part. Orbiting that brown dwarf, not the star, the brown dwarf, there is a third object, roughly the mass of Jupiter. It goes around once every 170 days. A thing, orbiting a thing, orbiting a thing. As far as anyone can tell, that is the first 3-tiered system of its kind we have ever seen. So what do you call the third one? Start with the obvious. It orbits a planet-like body rather than a star, and that is what a moon is. Being the third wheel in the system, as Hoy put it, makes you want to call it a moon. Except, look at the size of it. Take every moon in our solar system, Ganymede, Titan, Callisto, our own moon, all of them. Weigh them together. You would not get anywhere near Jupiter. You would not even get to 1,000th of it. This object is Jupiter. Calling that a moon is like calling an aircraft carrier a rowing boat because it happens to be tied to a dock. So call it a planet then. Except planets orbit stars. This one orbits something that failed to become a star, which is itself orbiting a star. Alice Zerlo, one of the co-authors, put it about as clearly as it can be put. In our solar system, there is a clean line between the planets and the Sun. So defining a moon is easy. In this system, the lines between stars, planets, and moons are blurred, and the whole thing becomes complicated. We built our entire vocabulary for other worlds by looking at one solar system, ours. And the galaxy is now handing back objects that do not fit any of the boxes. Which raises the question nobody can answer yet. How does something like this even form? There are 2 candidates. 1, it built itself out of a disk of gas and dust circling the brown dwarf, the same way our own moons formed around our giant planets. That would make it a moon in the truest sense, born exactly where it sits. 2, it formed somewhere else entirely, drifted and was captured, caught by gravity and locked into orbit. Those 2 histories look identical through a telescope and describe completely different objects. Right now, there is no way to tell which one happened. And now, the part I promised you. This is not a confirmed discovery. The European Southern Observatory, whose telescope made the observation, calls it the first plausible detection. Plausible, not confirmed. And that word is carrying a lot of weight, because no exomoon has ever been firmly confirmed. Candidates have been announced before. None of them has ever survived all the way. The observation was made with an instrument called CRIRES Plus, on the Very Large Telescope in Chile, and it is genuinely careful work published in Nature. But careful and confirmed are not the same thing. This needs more data before anybody should call it settled. I'm telling you that because a lot of the coverage didn't. So why is it still one of the most interesting results of the year? Because even if this particular object turns out to be something else entirely, the problem it exposed does not go away. We named everything out there using words we invented for here: planet, moon, star. Those categories worked beautifully for exactly one system. And we have now looked at thousands. Hoy's own summary was that we have essentially reached the limit of how far solar system terminology can be stretched. That is not a failure. That is what it looks like when a science outgrows its own dictionary. It happened to the word planet when we found Pluto's neighbors. It is happening now to the word moon.
So here is my question for you. An object the mass of Jupiter, orbiting a failed star 71 light-years away. Is that a moon? Is it a planet? Or do we need a word nobody has invented yet? Let me know in the comments, because the people who actually found it can't agree either. If you're watching this on Facebook, hit that follow button and share this video to spread the knowledge. And if you're on YouTube, hit subscribe and ring the bell so you never miss a journey into the unknown. Keep questioning everything. I'll see you in the next video, right here on Arthur's Physics.